Hi guys, Wesley here from Paradigm Cooling, and in this video we're going to show you the step-by-step procedure for testing a three-phase electrical motor. Now, while this task is a standalone task in the commercial refrigeration trade test in South Africa, it is important to mention that you will have to re-perform all these steps when you do the motor starter task, which is commonly known as the start delta. So it's very likely that you're going to have to do this test and everything that I'm showing you now the first time round when you have to test your electrical motor as part of that task, and then you have to redo all those steps when you have to do the start delta connection, possibly later in a different task. We're going to show you the mechanical tests on the motor, we're going to show you the electrical tests, and we're going to show you all the steps that you have to go through and all the things that you have to check and all the measurements that you have to take. For this task, we've got a motor ready to be tested. I actually don't know whether this motor is okay or not. I haven't tested it before. We've got our insulation resistance tester, commonly known as a Mega, and then we've got our multimeter for testing resistances as well as continuity. And then what I like to do is I like to just get myself a little board where I can do my little checks on. You can use a piece of page, anything like that, whatever you are comfortable with. But I go with the board because I can draw and things like that, and I can use the different color markers. So let's get right into it, guys, and we're going to show you exactly how to do this. And like I said, this video is actually part of a series of videos. We're going to do specific videos for the specific trade test tasks that you would have to do to pass a commercial refrigeration trade test in South Africa. That's in order for you to qualify as a refrigeration commercial technician, and it's how you get basically what is known as your red seal. And that is something that's important for everybody to have. And we're going to do a series of videos, just little tutorials on the trade test tasks that you can expect and how to go about them and your approach that you should have to them. So let's get right into it, guys. Okay guys, so as I mentioned earlier on, I like to operate with a little board here where I can actually just make little notes and then just do my checks one by one to see exactly what's going on with this motor. So I'm just going to show you my little setup on my board before I go anywhere before I start the actual testing. Just want to show you guys sort of my methodology and how I go about things. So when we test the electrical motor, there are two sets of tests. We've got the mechanical tests, which basically deals with the mechanical side and the physical condition of the motor. And then we've got the electrical checklist here, which deals with the actual windings and resistances and things like that, which is actually the meat of the whole situation. Just going down the list quickly, you can see on the mechanical checklist, we will check the overall condition of the motor. We'll check the condition of the foot mountings, whether or not they are all there and in one piece, and if they are in good enough condition to be mounted to the motor, to mount the motor in fact. Then we're going to check for the shaft for its straightness. We're going to check if the shaft is straight, if it's in a good condition. We'll check the bearing to hear if it's noisy. We will check whether or not the fan is straight and unobstructed. So we'll have to actually disassemble the motor before we actually can do those tests. And then we have to check for a nameplate, or what is commonly known as a tally plate, where we can get the information about the motor. Then on the electrical check side, we will first and foremost have to check the configuration of the windings. Hence you see this diagram here. The diagram actually serves a purpose whereby I can check the configuration, which is my first electrical check I have to do, and then I can actually draw it out on this little sketch using color markers so that I can sort of have it in my mind's eye exactly where the windings are running. What often happens is when these motors get rewound for whatever reason, very often the rewinders change the configuration of the windings. So it's very important that you check these consistently. Every time you put the motor in, make sure you're checking the windings. Even if there is a diagram, very often the motor has been rewound at least once, and in that case you often find that the windings aren't where they originally were in the diagram. So it's important to keep checking those. The next check we will do is the resistance reading across the winding. They need to be within 80%. So because there are 3 windings, it's a 3-phase motor. We will take the 3 readings of the windings, and hence you will see over here I've actually set it up so we can just fill in those numbers there, and then the difference, or the lowest reading across each winding has to be within 80% of the highest reading. So there can't be more than a 20% difference between the lowest reading and the highest reading, the resistance reading that is. So we'll have to check that as well. The insulation test is just to make sure that the insulation between the windings hasn't worn through, which will obviously cause the motor to short out. So we have to do a resistance test between the windings as well. And then the final electrical test is the earth test, where we will basically check for continuity between the windings and the actual body of the motor, to make sure that there isn't a dead short. All right, so let's get right into these, guys. Okay, guys, let's get straight into the mechanical tests. So if we look at my little list here, the first thing that we have to check is the overall condition of the motor. So if we go basically through this over here and we take a look around and we just do a simple physical test on the motor, or physical examination. If you go around and you check, the general condition of the motor seems to be pretty good, other than a little dust and so on it, seems to be fine. So if you look at that, that tells you, from what I'm observing, everything seems to be okay in terms of the overall condition. So we'll just go onto our list and we'll check that off. The next thing on the list to check is the foot mountings. Again, I'm going to reiterate, these are the mechanical checks. So this is basically the physical condition of this motor. It's going to be just what you're seeing: mechanical system, bearings, shaft, fan, and so on. Okay, so let's go on to the second thing on the list. That's going to be our foot mountings. It's going to be these bad boys here. What we're looking for is, we want to make sure that they aren't cracked and that they aren't damaged in terms of their physical condition. From here, these two seem fine. They are in a good condition. Let's go around the other side of this motor. And there you go. You can see these two are also in good condition. They're physically intact, which means we're going to have no problems with mounting this motor onto a base. So we can go and check that off the list. Shaft straightness. Now this is a tricky one to check. Usually when you turn it this way, you can immediately see if there's any kind of problem with how straight it is. What we can also do is we can also look at it from the side. It seems pretty straight to me. And what a lot of people will do is they'll turn the motor and sort of put a straight edge on it and try and see if there's some sort of movement. But this motor is a little bit tight, so it's a little bit difficult to get it to rotate for long periods. But I would say that that shaft is pretty straight. I'm happy that it's in a good enough condition. So we will check it off the list. The next thing we need to check is for bearing noise. We just turn the shaft now, and we're going to get it nice and close. We're going to get my mic nice and close to the shaft, and we're going to give it another turn, and we're going to just listen if there's any bearing noise. That's pretty quiet. All right. So I'm happy that we don't have an issue with any bearing noise. Then we're looking for fan straightness and unobstructed. Okay. This is obviously the fan over here. What we're going to do, we're just going to turn this motor slightly. I'm going to give it another turn. Well, that basically confirms that the fan is unobstructed and it's indeed straight. And the last thing to check on the mechanical checklist is the nameplate. So we're looking for a tally plate that gives information about the motor. And as you can see, we indeed do have a tally plate that's giving us all the information we need about this motor. So we can go ahead and tick that off the list. And from that short examination, we can obviously see that the motor has passed the mechanical checklist and therefore is mechanically sound to be reused. Again, I just want to reiterate the things that we're going to check in the mechanical checks. We check the overall condition of the motor. We check the condition of the foot mountings. We check for shaft straightness. We check for bearings noisy. We check if the fan is straight and unobstructed. And we check to make sure that there is a tally plate with information about the motor on it. And then that is it for the mechanical test. Let's move on to the electrical checklist. Okay guys, so we are back to do the electrical checks. And just a quick look through the electrical checklist. Get that in view. The first thing we're going to check is the configuration. Then we'll do a resistance reading across the windings. And then we'll do the insulation test. And lastly, the earth test. Okay, so the first thing on the list is the configuration. Basically what it is we need to find out exactly, as you can see, this drawing is a representation of the actual winding setup here. So what we need to do is we need to do a continuity test on these windings to see exactly which way around the windings are running, and then I just pen it in on this drawing, and that makes it easier for us to see exactly what is going on where. Okay, so we're going to do that first. How we do that is we obviously use a continuity test. So I have my just normal multimeter for that one. And then we're just going to check that there is continuity on the leads themselves. How we normally do is. And there you can hear there is a beep, so there is continuity. So obviously, when we find the right terminals for each winding, it will give off the beep and it will tell us exactly where the winding is running. So how I usually do it is I just mark the top three, U1, V1, and W1. And then we check the continuity that way to see exactly which way around the windings are running. Okay. So I'll just start at the very first terminal and we'll work our way until we get a beep. There's nothing there, nothing there. There's our beep. So obviously that winding is running between the blue wire and the brown wire. And with it being on the motor this way, you'll often find that this is how they'll test you at the trade center. And then as we can see, this winding runs across this way. So the first thing we're going to do there is we're going to just mark it accordingly on my little sketch, and that winding ran from there across to that terminal. Okay, and then we just repeat that process 3 times until we find the exact configuration of all 3 windings. So we've confirmed that the first winding runs between there and there. That will be U1 and U2. In fact, let me just mark it on my sketch as well. That's U2. Okay, and then we'll check the next one. We'll do exactly the same test. And we got lucky on the first attempt. So this winding runs between the lime wire and the red wire, which is across this way. We will mark that also on the drawing. It's V1 to V2. V2. And then if you look at this drawing, it's obviously telling you that the third winding should be running W1, W2 in that configuration, but let's just double check that anyway. We just check all of them again. Nothing. There we go. So that's just confirmed exactly that what we thought it would have been. We've gone W1 to W2 in that configuration. So let me just mark it with my little black marker. W2. So as you can see, so we've confirmed the configuration and we can check it off our checklist. The next thing we need to do is we need to take a resistance reading between the windings, or we need to at least take a resistance reading of each winding, and then we will just fill in that information over here. Okay, so what I'll do is I'll just leave that board there so that we can work out exactly go. Just changing my tester. So the first one we're going to look for is the resistance between U1 and U2, which is the first terminal at the top and the last terminal at the bottom. So what I do is I'm just putting the board over there, and let me see if I can get my tester into the view. There we go. Let's see if we can just get it in there somewhere. That should be it. And then we're going to just do a resistance test between U1, which is this one, and U2, which is this one here. That looks like 4.1 ohms. Okay, so we will just put it in there, 4.1 ohms. Right. Now we need to find the resistance between V1 and V2. And V1 and V2, that resistance is going to run between this terminal here and this terminal here. So let's just see what resistance we get across there. Sorry, just lost. And that is 4.0. So let me just change the color of that marker so it's easier to see. So V1 and V2, we had a resistance of 4.0 ohms, as you can see there. So the last one we will have to check is, oops, tester just fell, W1, which is that one there, and W2. Just get my tester back in position. Fantastic. Okay, as I said, this is going to be W1 and this is going to be W2. So we're looking for a resistance reading across that one. $4.3. To another different color. So, let me just clean that up. That looks horrible. There we go. So we have now a resistance on the third winding of 4.3 ohm. And as you can see from the three resistances, it's quite obvious that they are very close together to each other, and that's well within the 80%. We could sit here and we could do the math, but that's pretty close, which means that the motor has passed the resistance test. So we can tick that one off the board as well. So the first two electrical checks the motor has passed. The next check we have to do is an insulation test, which is basically also a continuity test between the windings. For this particular test, what we will do is we're actually going to get the resistance tester in here. So we're just going to very quickly get the resistance meter in, or the mega as it's known, as it's often known. The funny thing about that is that mega is actually a manufacturer's name for an insulation test, and people just in South Africa have just gotten used to calling it the mega over the years. But that's actually an insulation tester. So what we're going to do is we want to make sure that there's no leakage between the winding. So we want to make sure, as you see there, that's why we're calling it the insulation test, because we're actually testing the insulation between the windings to make sure that there isn't some sort of leakage and that the windings can't arc on each other. So what we're going to do quickly is set up the insulation tester, and then we're going to do that test. Okay guys, so right now we're about to do the insulation test. Alright, so we've got the mega all set up, and all we have to do is check for continuity or any sort of reading between the windings. So what we're effectively going to do is we're going to check between each of these windings to see if there is continuity or any sorts of reading. Right, so first thing we're going to do is we're going to get our Gorilla clamps on there. Nice and solid. That one on there as well. And then what we're going to do is we're going to set our resistance tester up to 500 volts. So what we're going to do is I'm actually going to run the test and then see what the reading is. Alright, so as you can see, the reading we're getting between those two windings is 1.42 gigaohms at 525 volts. That says that there's no continuity, so there is no seepage between the actual, there's no leakage through the insulation between the windings. 1.42 gigaohms is quite a good reading, which means the insulation is still in a very good nick. Let's go ahead and let's swap it around to one of the other windings. Just make sure that it's on there nice and tight so you get a good solid reading. And then I'm just going to bring the insulation tester back up. Going to go back up there and let's run the test. There you go, 4.2 gigaohms. Also, no beep, no leakage through the insulation, which means the insulation between those two windings are also holding nicely. Let's move on to the last winding. Again, just make sure she's on nice and tight. That's why I like using these Gorilla clamps. Okay, bring it up again. Again, we take it up to 500. 500 is sort of the standard when you go and do your trade test. Most people, when they do this test with a motor, they take it up to 500. Let's push the test button and let's see what reading we get. And again, we're getting 2.9 gigaohm, which means that we can go ahead and shut this down. We can take the Gorilla clamps off. And I am quite happy that the insulation is in a good condition. So we can actually go ahead and tick that one off the list as well. So thus far, for the electrical checklist, we've done the configuration. The resistance readings are within 80% of each other, and the motor has passed an insulation test. So there's one test left to go, which is the earth test. So for me to say earth test, that's obviously not very descriptive. But what we basically want to check is we want to make sure that there's no continuity between any of these windings and the actual body of the motor. So again, it's going to be the same test that we just did, except this time around we're going to do the continuity check, the resistance check at least, whichever one you want to call it. We're going to do between the winding and the actual body of the motor. So we're going to do exactly the same thing. We're going to put our Gorilla clamp on first winding, and then we're going to put the other Gorilla clamp on the earth terminal. Just make sure that's not touching anything else. So we've got the Gorilla clamp on the first winding and on the earth terminal. Oopsie, just come off. Just put that back on again. Okay, that's not actually very tight. So what I'm going to do is I'm actually just going to give it a little bit more torque so that we can get a decent grip on that. And there we go, that should be fine now. So let's do the test again. So what we're going to do is, again, we're going to switch it on. We got to 500 as usual, and we're just going to push the test button and see if we get a reading. Here you go again, 1.35 gigaohm, which again says that there's absolutely nothing going on, or very high level of resistance between the winding and the actual body of the motor, which means that the first winding, which is the U winding, seems to be in good nick. There is no continuity between it and the body of the motor. So now what we're going to do, we're going to move on to the second winding, which is the V winding. I'm going to do exactly the same test. Okay, get it up at about 500, and then on the test, 933 megaohm. So that winding is also fine, it's not arcing against the body. I'm happy with the second one. And then last but not least, we're going to check the W winding. Just make sure this is nice and snug. And then we're going to go again. We're going to let the machine test. 2 gigaohm. 2.2 gigaohm. Fantastic. Okay, so there is no short on this motor. I am happy that the windings aren't shorting against the body. There is plenty resistance and no continuity, which means the motor has passed the earth test as well. So now when you look at it in its totality, let's grab it around here quickly. All right, so when you look at it this way, The motors passed all the mechanical checks. It was overall in a good condition. The foot mountings were good condition. The shaft was straight. There were no bearing noises. The fan was straight and unobstructed, and it had a tally plate, a nameplate on it that gave us all the information we needed. So it passed all the mechanical checks. When we came over and we did the electrical checklist, we did the configuration first. As you can see here, we did a detailed drawing of the configuration. We took resistance readings, as you can see there, and we confirmed that they were within 80% of each other when you look at these figures. So it passed that as well. The insulation test came back good, and the earth test came back good as well, which means this motor is good to be used. Now, again, just a reminder, guys, that this test has to be repeated. If you get given the testing of an electrical motor task in the trade test, you will have to perform this task as I just showed you now, and you will have to detail on your page exactly the steps you've taken. So you have to obviously write everything out, the steps that you've taken, everything you've done, including your safety checks. And you've got to do all of that. And this is the complete test. Obviously, you have to write everything out. We're not going to do that now. That's a complete test to test the three-phase electrical motor. Again, very important reminder, guys. It's a different motor that you will have to install onto your star delta configuration. So the motor starter task is going to have a completely different motor that you would have to attach to the control system from the motor that you use to test for this task, which means it's very important that you have to redo this test on the motor when you do the star delta configuration. Anyway, guys, that's the video. If you like this content, please check out our other videos in the series of tasks for the commercial refrigeration trade test in South Africa. Until next time, guys.